Okay, today we're gonna do 2.3. The limit laws. So we studied limit last time. So what is the limit? We evaluate the function when x approaches to a number, right? Okay. So here, let us start this one because we did this one last time. Basic limit result. Did the last time. So first one, limit x approach to a, x is to a. Second one, limit x approach to a, c equal to c. All right, so let us do this. Let me write down, find. Limit x approach to 2x. What do you get this one?
2. 2.
2. Good. It's 2. And second one, limit x approach to 2. We have a constant. What do you get this one?
5.
It's a 5. Thank you. Good. All right. Now, let me write down the theorem 2.5. Limit laws. So let me make it short. I don't put a lot of English there. So two function we sum there. Then we can split term by term. Oh, the condition I didn't write down. The condition x approach to a, f of x equal to L. Limit exists, goes to L, and limit x approach to a, g of x, limit exists, that limit goes to m, okay? Then we get L plus m is a number. Any number for L and m, okay? And let me do like this, subtract here, okay? And I want to use a subtract here and subtraction here, all right? Now, if we have a coefficient, constant in front of the function, then we can take out the constant outside of limit. Then that, okay? Then we have C constant. L and C. Then this limit x approach to a, f of x goes to L. So we have L there, right? And we have a multiplication. Also, we can split like this with the multiplication, right? And then we know that limit exists when x approaches to a of f of x, then goes to L, and g of x goes to m. So L times m, right? And quotient, so g of x cannot be equal to 0 also, m cannot be equal to 0. So we can split as well, numerator and denominator. Then we know that L over M, okay? And there's two more. Since we don't have a space, so let me use it like that. Power from x to the m power. Then we can do this way. To the m power, but look inside the limit, right? So x approach to a, limit of f of x goes to L, it will be L to the m, right? And then they indicate positive integer. And last, we have a root. X approach to a, square root of n, f of x. Then we can express this one like this. So we put the limit inside the square root. Then look at the inside the square root. Not square root, nth root, right? This one goes to the L, right? So we have the nth root of L. Okay, so let me write down for L. Okay, so let me erase. Okay, so let us do this one. X approach to -3, and then limit of this function. Okay, so basically two functions there. They indicated that, right? But we say just two terms. That's fine. Okay, then we can split to two terms. So we have like that. All right. So look this one. X approach to -3. Then we can plug in. So your book indicate that the 4s coefficient constant, so take out. So what is this? When x approach to -3, limit of 2 is?
2.
Thank you. Okay. How about this? We just learned the first page one, right? What do you get this one?
-3.
It's -3, right? So plus 2 equal to, can you please calculate 4 times -3 plus 2?
-24.
-24. Okay. Is it -24?
-10.
-10?
Oops.
It's okay. All right. So this one we split like limit by limit laws, okay? But we can just directly substitute when x equal to 3 there, right? So we need to get used to it a little bit. So this is a quotient, so we can split numerator and denominator, right? Okay. Now, we can take out all the constant, right? Like earlier, but we can just do that. This is the first time, let us do that, just follow. So what is this? When x approach to, I'm doing denominator. When x approach to 2, x cubed, what do you get?
4. 8.
You guys, you guys do.
A day of errors, I guess.
I cannot trust you anymore. Since the first day, how many times you guys give it to me wrong answer? Okay, I'm just kidding. It's possible all the time. We make a mistake all the time. So in the beginning, so let me just follow the steps. Okay. X cubed split. All right. Because this is the beginning. So in the denominator, we know that 2 cubed. Denominator, I'm doing denominator. When x approaches to 2, what's the limit of 4? Shy to talk. Scared to talk now.
4. This one I know is
4. Okay. All right. Then I'm doing numerator. The first term, we have 2 there. Now, what is x approach to 2? X squared.
4.
Yes. 2 squared. Okay. 3. Then we do times 2 for the second one. And how about the third one? The last term, x approach to 2, limit of 1.
1.
1. Okay. Now, hardest part, calculation. Can you please calculate?
I get 1/4.
1/4. How about others? Agree? Okay, thank you. Let me erase. Number 3. Okay, then you might realize if there is a polynomial, if there's a limit, then most of the time we substitute the number, right? So let me write down this one, the theorem. 2.6. X approach to A, cube X equal to cube, right? So just substitute when X approach to A and cube A, okay? And same as this one. So cannot be denominator is 0, right? All right, now everything will be easy. So 3. Okay, so we just learned limit of polynomials and rational function. Okay, we just substitute this number into function, right? So 2, 3 squared, 3 times 3 plus 1 over 5, 3 plus 4. Can you please calculate? What do you get?
I get 10 over 19.
10 over 19. Thank you. All right, so we're gonna do a little bit advanced. X approach to 1, x squared minus 1 over x minus 1. Okay, so we're gonna learn techniques. So here, when we have this kind of example, then we should calculate in our brain, especially look at the denominator. When substitute 1, what do you get? Denominator
0.
Yeah.
0, right? Yeah, so 0 in denominator is undefined, which is not good one, right? But then also the numerator, your classmate said that 0, right? 0 over 0 is more worse one, right? So we call this is indeterminate form. So we're gonna talk about this one deeply in 4.8. Okay. So then how do we do this one? We're gonna learn this technique. Look. X squared minus 1, can you factor out?
Yeah.
Yes. So we have a squared minus b squared, which is a minus b, a plus b, right? So this will be x minus 1, x plus 1 over x minus 1. Look, we can simplify, right? Now we have only x plus 1 left. Okay, you don't need the parentheses. Now we can substitute. No problem with that, right? So this will be 1 plus 1. Now you can do it. 1 plus 1.
2.
1 plus 1. You can do it. Last chance. 1 plus 1.
2.
Good. Excellent. Right? So this is, we called factoring out and canceling technique. Okay? You don't have to memorize the name, right? Just to learn the technique. How about this one? I need your help. X approach to 3x squared minus 3x over 2x squared minus 5x minus 3. Okay. I'm gonna do easy one, you do hard one. So I'm gonna do numerator. So can you please factoring out the denominator? This is a rule. I'm gonna do easy one all the time, okay? Because I'm a teacher. You should laugh. This is joking. Why you guys serious? Okay, so I'm gonna factor out this numerator x minus 3 over, what do you get, denominator? How did you factor out?
2x plus 1 and then x minus 3.
X plus 1, x minus 3. By the way, this one is 0 over 0, right? Okay. So let us check that. This is a positive 1x. And this is negative 6x. Makes a negative 5x. Yes, right? So we need to always check. Now, the bad one is gone. We simplify. That's why we need these techniques, right? Then we have x over 2x plus 1. Okay. Now, we can substitute x for 3, right? So what do you get?
3 over 7.
3 over 7. All right. So is it okay? So if we have 0 over 0, then this is one of the technique. We can find the limit this way, factoring out and we canceling, okay? Now, we have another technique. Let me erase. What number is this? 5?
I think we just did 5. I think this is 6.
6. Thank you. Limit x approach to negative 1, x plus 2 minus 1 over x plus 1, right? So let's plug in negative 1 into x, then we get 0 over 0, right? Now, we see radical there, then however, yeah, you learn from the intermediate algebra, right? Multiply by conjugate. So this means we keep the same format, just the sign is different. So we multiply x plus 2 and 1 only sign different, which is plus. Since we do numerator, we must do denominator because we make 1, right? So technically, we did something, but literally we did not do anything because multiply by 1, right? Now, so we do the formula difference square. What is called? We did earlier a square b square, right? So that's a minus b and a plus b. We do backwards right now, okay? So we have a minus b times a plus b. So a in this case, square root of, look, and 1 square. Can you see that? Okay, then there is x plus 2. X plus 2 minus 1, right? And please don't multiply denominator. Because we want to simplify, okay, the bad one. Like earlier, factoring out, and we do simplify, right? Canceling out. Okay, so that's here. We multiply by conjugate techniques. We need to simplify the bad one. So we have x plus 1. Then we have square root x plus 2 plus 1. Okay, now x 2 minus 1, what do you get? You can do it. 2 minus 1.
So it's just x plus 1.
X plus 1. Thank you. X plus 1. Now, we can see that, right? We can simplify. All over this. So as long as we don't get the 0 in denominator, we are safe, all right? So we can just substitute right now. So 1 over square root -1 plus 2 plus 1. So what do you get?
1/2.
1/2. Thank you. This is the answer. Okay. Let me erase. Okay. 7, right? Okay, look at this. Always we need to check the denominator, right? So if denominator is not undefined, then we are safe, okay? But look, we plug in 0, it's undefined. It's not good, right? Then what do? Make a common denominator. So what is the common denominator?
X.
and x minus 5, right? So this is not good. Hold on. So x minus 5. So we have x minus 5 and plus 5, right? Okay. Then this is 0, negative 5 plus 5. We get x over x minus 5. Okay. Now we can simplify x over x. Then we get this. Now we can plug in, we can substitute, right? So what do you get? So 1 over 0 minus 5, which is
Negative 1 over 5.
thank you. Okay. All right. So now this is what we did the last time. Okay, this graph is like that. Square root, right? Okay. Then we are approaching to goes to 3 from the left. So what is the limit of the function?
Undefined?
Does not exist. Good. Because there is no graph, right? There's no function. Okay. How about the right? So I'm standing here. I'm going to 3 from the right. So what do you get this one?
0.
0. Good. Okay, let me erase. Number 9. This is also we did the last time. Piecewise. So this one, let me show you. The top one is a straight line. This is a 5. And like this. Oops. Cannot do. Okay. It's 1. Right. So when x approaches to the left, what do you get? So probably I'll make like that. 5. Thank you. So let me make a little bit obvious. Okay. Better. Okay. So it's a 5. Good. How about limit x approach to 2 from the right? It's 1. Good. Now, we did not have that, right? Because one-sided limit last time, right? And then I wrote down, what if we say that x approaches 2, then I erase because one-sided limit. But in this case, they ask us, what if x approaches 2 from left and right, even though one-sided limit, right? So it does not exist. Good. So this is what we did the last time. Very good. Okay. All right, so let us do next one. Let me erase number 10. X approach to 2 from the left, x minus 3 over x squared minus 2x. Okay. What happened? What happened when x equal to 2? What is called what?
It's indeterminate form, so you have to. It doesn't work.
Oh, indeterminate form is 0 over 0.
Yeah, but that was what you're asking, right?
What if x approaches to 2? What do you get in the denominator?
Oh, when it approaches 2.
Undefined.
Yeah.
Undefined, right? So undefined, that is the same as a vertical asymptote as well, right? Can you see that? Okay. So I'm gonna give it to you a tip. That's correct. On indeterminate form is different with undefined. Undefined means if a denominator is 0, it's undefined. So different terminology, right? Different vocabulary. We call this is indeterminate form. So we're gonna learn this one more advanced in 4.8 in this book. So 2 over 0 undefined, right? Any number over 0 is undefined. So it reminds me my pre-algebra course. 0 cannot be denominator, undefined, undefined. We did a chant all the time. All right. So then, look, this one we can do. All right. Then let me give you a tip. This one I want to factor out. So x and x minus 2, right? Okay. So undefined means is also not means. It's also telling us vertical asymptote as well, right? Let me denote like a VA, right? So vertical asymptote. So what's a vertical asymptote look like?
It's like a line going like in the direction of the y-axis that the function can never touch.
Like that, right? So then what's the function behave? Behave like infinity or negative infinity like that, right? Because you say that, you just said that, never touched, right? Okay, so we're gonna check the behavior. Okay, let me give you a tip. So 2 from left, say 1.9, okay? Then we plug in 1.9 minus 3 over 1.9, 1.9 minus 2. So we're not gonna calculate because you guys not good in calculation part. I'm just kidding. We're gonna just check that plus minus sign, okay? So numerator, we get negative, right? Denominator, we get 1.9 is positive, 1.9 minus 2 is negative, right? Can you see that? Then this is the 2 negative sign, which is positive. So in the vertical asymptote, positive means positive infinity.
So how come we need to factor for this one if we're just going to substitute 1.9 instead of 2?
Oh, you can just calculate then.
Oh, okay,
You don't need to sign analysis, okay?
cool.
Or sign analysis is more easier instead of calculation, using calculator, okay? Because decimal, we don't like decimal. All right, done? So we can just say that this is positive infinity. Okay, good. I cannot say your name. All right. Okay, let me erase. So if they ask us x approaching to 2 from the right, then we can say the 2.1 and substitute, and then we do sign an analysis, okay? So just positive or negative. Negative means goes to negative infinity, all right? Okay. All right, so 2.7 theorem. The squeeze theorem. So other textbook indicate the sandwich theorem. Is it correct spell? Sandwich, like food sandwich? Okay. All right. So let me write down just to function like this. Okay. Then take the limit. X approach to A. F of X goes to L. And also, we have a limit for the H of X. When X approaches to A, then goes to L as well, okay? Then, look at the G of X. It's between there, right? So we can conclude the G of X also goes L as well. Okay, let me show you like so let's say this is of X. This G of X. I don't know how to make nicely. So this L. Okay. G of X in the middle. And then H of X. All right. Ugly picture. So we have 10 minutes. Let's do this one. Do you remember this one? We did that last time. I showed you this one like a table. Does anyone remember this one? No, remember? This one like this, you probably remember like that. And then there is a hole like this. And then here is the one. Do you remember? Okay, anyway, this is goes to 1. Okay, so I showed you table and then I asked you what the limit is. Okay, you guys say the answer, it's 1. Okay, so let me show you why this is 1. And this is the second time we see this one, this one. Okay, limit when theta approaches to 0, sine theta over theta, which is 1, right? So we're gonna use this one several times more in the future. So please remember this one, okay? 5 stars. Let me give you 5 stars. Okay, let me draw a unit circle. So we know that the radius equal to 1 because, right? So this is 1 and 0. Also, this is the first coordinate correspond cosine theta, and second coordinate corresponds sine theta, right? Oh, sorry. Come on. Ah! Do again. Why all the time? Clumsy. Sine theta, sine theta. We know that from the tree. Let me draw the triangle. A little bit, okay. So make sure there's triangle, okay? Now we have to understand this one. We have angle theta there, okay? From this angle theta, look, I want to express like opposite side. I want to know about this side. Make sense? Then, do you agree tan theta equal to opposite? Let me just denote like OPP, right? Opposite over Jason, right? Because sine over cosine. Make sense? Yes or no? Yes or no? Mm-hmm.
Yes.
Good, thank you, Jason, right? Okay, now, then opposite, then we times Jason side, right? But then Jason is in this case, it's 1, right? The length is the 1. Can you see that? Jason side is, which is 1. So opposite side, cannot spell right. Equal to Jason is 1 times of tangent, right? Okay, so I'm gonna write down this length is 10 theta. Do you agree? Okay, now the theorem. Let me take out here. This is 10 theta. 10 theta, it is 1. Okay, now what's the area of triangle? Is 1/2 base times of height, right? So then what's the base? Base. What's the base?
One.
It's 1. Height, which is 10 theta, right? Okay. Now, this is greater or equal to, and let me take out the sector here, black here. Can you see this one? Okay. So then this will be like this, right? Not good in the drawing. Okay. So also triangle with the sector. Then area of sector will be, you don't remember, so let me write down theta r squared over 2. Okay, then what's the r in this case? R, radius r, what is that?
There's 1.
Yeah, it's 1. Look, it's a unit circle, right? It's 1 square over 2, which is theta over 2, right? Okay, now I want to make here okay, this triangle. So let me write down. So area of triangle, okay? So this is also 1/2 times base times of height. Okay, this height is the y, right? Can you see that, the red one? Red one is y, so this is corresponding sine theta. Do you understand what I'm saying? This one. Okay. Now, so this is 1/2. What's the base? What's the base?
I don't know.
Oh, sorry.
Cosine theta.
No, you should be like this. Sorry about that. The picture is not clear. So I should not draw it like that. So it should be like that. So it's
So is it still just 1?
yeah, it's 1, right? Okay. So this is sine theta. Okay. All right, then this is 1 and h, which is sine theta. Okay. So look. So this will be 10 theta over 2 greater or equal to, we have a theta over 2 greater or equal to sine theta over 2, right? Now I want to multiply 2 over sine theta every side. Okay, so then, so basically like that. Okay, so what do you get? So 2 over sine theta, look, sine over cosine, so sine simplify, right? For the first one, so we get 1 over cosine theta. It's okay? Okay, 2 is canceled out, and we get theta over sine theta. Okay. Then the last one is 1. Can you see? So multiply by 2 over sine theta, right? Now, we do reciprocal and the reversing the inequality. So since reciprocal, then we change the inequality symbol. So like that. Okay, almost done. And let us do one more problem. Then look, let's take the limit. Take the limit when theta approach to 0. Okay, so theta approach to 0. What's the cosine 0? What is cosine 0? It's 1. Thank you. Then what's the theta approach to 0? What is the limit of 1? When theta approach to 0, what's the limit of 1? What do you get? It's 1. It's constant, right? Constant is always constant. Okay. Now, then we can conclude, right? By squeeze theorem. So this one as well. Sorry, no space. So limit sine theta over theta when x, not x, theta approach to 0, we get 1 as well. Okay, by squeeze theorem. Sorry, no space. You guys okay? All right. Someone say something in the chat. Yeah. Okay, can we do one quick problem? Okay. Let me erase. Sorry. Okay. Sure. All right. So this is the last one. Why I put the in the bottom? Oops. Yeah. Okay. This one we're gonna use a conjugate because 1 minus 1 is 0, 0 over 0, indeterminated form, right? Sorry. So 0 over 0. So multiply by conjugate will be 1 plus cosine theta, 1 plus cosine theta. Okay. Now, same. So we have a square minus b square, which is a minus b, a plus b, right? So we do backwards. A squared, which is 1 squared, minus b squared, which is cosine squared, right? Okay, so let's write down. One squared, 1 minus cosine squared theta. Okay, so don't multiply with the denominator, right? So we need to simplify later, canceling out. All right, then look, we have the Pythagorean identity, right? So let me just make ID. Cosine squared theta plus sine squared theta, which is 1, right? Then we can say that sine squared theta, which is 1 minus cosine squared theta, right? So numerator, we can say understand you forgot everything trick, that's fine, okay? But from now on, when I mention that, you should refresh every trigonometry stuff and then remember, okay? From now on. So like this, Pythagorean identity like this, okay? So from now on, you forgot before, yes, that's fine, okay? But from now on, please remember. All right, so we have sine squared theta there. All right, then look, we can split this one. Can you see that? We learned earlier in multiplication, we can do that, right? Okay, look, what is this? What is this? Does anyone remember?
1.
It's 1. Okay, we just did. I showed you why this is 1, right? Then, looking at the denominator, the denominator, when theta approach to 0, what's the cosine theta? Cosine 0.
1.
1. So 1 plus 1, which is? What is that? 1 plus 1. 1 plus 1, what do you get?
2.
2, thank you. It's a 2, right? Now, what's the sign 0?
0.
0. So, as long as denominator is not 0, we are safe, okay? Then, what do you get? 1 times 0 over 2.
0.
0, okay. All right. So any question about the lecture? So let me erase this one.